Welcome to the lesson on exercise 9b, which deals with slightly harder equations, multi-step equations, equations which have brackets and fractions and letters on both sides, variables on both sides of the equal sign. Just a quick recap of last lesson. These are the four basic operations you can do when you are solving equations, as long as you do it to both sides. Okay, and the first of these is you can add a number to both sides. um, I guess you can think of a very simple example, I guess. Uh, I'll do it in red pen actually, just so it stands out. So for example, this is a true equation. By equation, I mean that there is an equal sign. And on the left-hand side of the equal sign, we have 1 plus 2. And on the right-hand side of the equal sign, we have 3. So that's an equation. It's got an equal sign. And we're saying the left-hand side is exactly the same numerically as the right-hand side. 1 plus 2 on the left-hand side and 3 on the right-hand side. They're both the same. That's what we're trying to say here. 1 plus 2 is the same as, equivalent to, numerically speaking, in terms of maths, it's the same as 3. Now you can add a number to both sides and that statement will still be true. For example, if I add plus 5 to the left-hand side, that equation is no longer true because 1 plus 2 plus 5 does not equal to 3. However, because I added a 5 to the left, if I add a 5 to the right as well, it's now true. 1 plus 2 plus 5 is equal to 8. And on the right-hand side, 3 plus 5 is also equal to 8. And so we conclude that you can add a number to both sides and the equation will not change. So that is a valid operation. You can add it up. You can add a number to both sides and the equation won't change. Okay. Similarly, you can subtract a number from both sides. If I do -1 here and I do -2 there, that is not a true equation anymore because I subtracted different numbers on both sides. If, however, I were to subtract 1 on both sides, then my equation will still be true. I'm allowed to subtract 1 on both sides. 1 plus 2 is 3. 3 minus 1 is 2. So on the left-hand side, I've got 2. On the right-hand side, I have 3 minus 1, which is also 2. And so left-hand side is equal to right-hand side. That's a valid operation. I haven't changed the equation. I'm allowed to do that. Now, next thing to understand is you can also multiply every term on both sides by the same number. Okay, so for example, if I multiply the 3 by 2, if I do times 2 here, then the right hand side is clearly 6. Now, if on the left hand side I multiply only the 2 by 2, if I do 2 times 2 only, I will have 1 plus 4, which is 5. That is not a true statement. On the left-hand side, I have 5. On the right-hand side, I have 6. And what I have to do is I have to multiply every term. I have to multiply the 1 by 2 as well. I have to multiply every term on both sides by the same number, and that is a valid operation. So 1 times 2 is 2, plus 2 times 2, which is 4. So 2 plus 4 is 6. On the left-hand side, I have 6. On the right-hand side, I also have 6. And that is a valid operation. And that's where these basic rules come from. Just common sense, just basic logic, and just trying out basic things. And similarly with division, you have to divide every term on both sides by the same number. Okay, so as long as you keep these rules in mind, as long as you apply them correctly, that's all equation solving is. Really, honestly, that's all it is. So let's have a look at some of the harder question, quote unquote. And let's have a look at this question. Solve for open bracket x minus 1 close bracket equals 16. And remember, if I change one side, I have to change the other side of the equation as well. And when I say side, obviously, I mean, this is the equal sign, right? To the left of the equal sign, that is the left hand side. That's one side. On the other side of the equal sign, that is the right hand side. If I change the left hand side, I have to change the right hand side by the same amount. That's if I change it. Okay. Like if I mathematically change, if I add something, if I subtract something from one side. Anyway, so let's get started solving the question. What I'm going to do is I'm going to expand the bracket. I'm going to expand the bracket. Now, expanding the bracket does not change what you already have. Because all I'm doing is just multiplying what I already have, right? 4 times x is 4x, and then 4 times -1 is -4. Now, notice I have not actually done anything. I've just expanded the bracket. It was already there. It's like unpacking a box. If you get a box in the mail and you unpack it, it's not like you have anything different. You already had the box. Okay, so I've just unwrapped this, so to speak. I've expanded the bracket. I haven't changed anything. Now I'm going to, because I want the letter to be by itself, I can add a 4 there and add a 4 there. Okay, so -4 plus 4 will cancel each other out, and I'll be left with just 4x is equal to 16 plus 4, which is 20. And then because it's 4 times x, I can divide by 4. And this is basically the same as what we did last lesson. Divide by 4, I'll have x is equal to, and then 20 divided by 4 is 5. And I'm done. So even though it looked a lot harder, it really wasn't. It was just basic rules. You add 4 to both sides, which is rule number 1. And then I divided every single term on both sides by 4, which is rule number 4. Moving on. Now, this is going to be very similar. I'm just going to expand the brackets, and then let's see what happens. 3 times 2x is 6x, plus 3 times 4. So I multiply this, and then I multiply that. And then I'm going to multiply these two. But for the timing, let's just focus on 3 times 4. 3 times 4 is 12. Plus, now I'm going to do 2 times 3x, which is 6x. And then 2 times -2, which is -4, equals to 20. Once again, I haven't really changed the left-hand side per se. It's still mathematically the same. I've just unwrapped it. And now I'm just going to add like terms on the left-hand side. I'm not adding a random number. I'm just adding like terms, what I already have. Like you have a 12 and you have a -4. 12 minus 4 is just 8. So all I've done is I've just done the operation 12 minus 4. And I don't have to touch the right-hand side because I haven't done anything. You know, it was already there. 12 minus 4 is 8. I'm just simplifying it. 6x plus 6x is 12x. And 12 minus 4 was positive 8. So it's going to be plus 8 is equal to 20. And this is what we had last lesson. We arrived back at what we had last lesson. So that's why it's important for yesterday's lesson. If you did not do questions 8 to 11 or 7 to 11, please make sure you do it. I will have marked your work incomplete and not done because it builds up. Everything builds up. Even the stuff we're doing today, when we move on, when we get to the harder equations, then generally what happens is the harder equations, after 1 or 2 steps, will start to resemble what we're doing today. And then today, after the first step, starts to resemble what we did yesterday or on Wednesday, the last lesson. So it's just more steps get added. Anyway, so you do -8 on both sides, and you'll be left with 12x is equal to 12. Divide by 12 on both sides, and you're left with x equals to 1. And I'm done. Moving on. What about if you have something like this? Okay, many students get confused when you have an x over there and an x over there as well. Simple solution, just move all the x's to the same side. So I'm going to subtract 2x here. I'm going to subtract 2x here. When I subtract 2x here, obviously 2x minus 2x is just 0, right? So I'll be left with just -11. But that -2x, if I do it to the right-hand side, obviously I have to do it to the left-hand side as well. So you can add or subtract any number. So look at rule over here, add a number to both sides or subtract a number from both sides. Over here, I'm choosing to subtract the number 2x. 2x is a number. Remember, x represents a number. That's what algebra is all about. We represent an unknown variable with a letter. And so it's still a number, really. I just don't know what it is, but it doesn't matter. I don't need to know. I just have to subtract it. So I subtract 2x on both sides. On the right-hand side, that will cancel out with that. I'll be left with just -11. On the left-hand side, 7x minus 2x is 5x. And then you have plus 9. And now that's back to what we left off on Wednesday. So I'm going to do -9 here, -9 there. So you'll have 5x is equal to negative 11, negative 9 is negative 20. Then I divide both sides by 5. And I'm left with x is equal to negative 20 divided by 5 is negative 4. If you're not sure, make sure you use the calculator. Okay, looking at part B. Now, once again, I've got variable on both sides. And because, it doesn't matter how you do it. So I'm going to choose to remove this over. I'm going to choose to get rid of that 2x. I don't want there to be x on the left-hand side. So far, I've been doing letters on the left-hand side every single time. But I guess if you write 1 plus 2 equals to 3, you can very easily write 3 equals to 2 plus 1. It's the same thing, isn't it? So writing x equals to 5 is exactly the same as writing 5 equals to x. It's exactly the same. It doesn't matter how you write it. And so what I'm going to do now is I'm going to subtract 2x on both sides. Subtract 2x here, subtract 2x there. I'm subtracting the same number from both sides. So that gets canceled out. I'm left with just 5 on the left-hand side. On the right-hand side, you have 5x minus 2x, giving you 3x plus 11. And then now we're back to what we were doing on Wednesday. I subtract 11. I want the letter to be by itself, remember? I want the x to be by itself. So I'm going to undo whatever is with the letter, which namely is 3 and the 11. So I subtract 11 on both sides first. Left to just 3x is equal to 5 minus 11, which is negative 6. If you're not sure about that, use a calculator. 5 minus 11. Calculator will tell you the answer. And then you have 3x. I want the letter by itself, obviously. There's a 3 still there, 3 times x. So I'm going to divide by 3 here and divide by 3 there. And x equals to negative 2. Once again, negative 6 divided by 3. If you're not sure, use a calculator. Is equal to negative 2. And I'm done. And as you can see, I'm not doing anything fancy. I'm literally just applying the same rules. Even when equation solving gets hard, it's just a matter of practice. You guys are more than smart enough and capable enough to be very good with algebra and equation solving. It's just a matter of practicing. Just practice, just get used to it. It's just it's a skill, fundamental skill as far as high school maths is concerned. And it will open the door to many careers for you as well. I know many students like to say, when will we ever use this? Well, you will use it if you get into a career which requires it, So just get good at it. And then when you get to uni, you'll see all the study that you do, you definitely use this stuff. Okay, moving on. Over here, now I'm going to, okay, so this is one term. That is one whole term. As a general rule, when you're faced with a term like this, you want to get rid of the denominator because our goal at the end of the day is to get the x by itself. That's my goal. I want the x to be by itself. So what is with x? What's with x is that 2, and there's a positive 3, and there's a divided by 4. So that's what I have to undo slowly, step by step. So I have to undo those. I have to do the opposite operation of these, right? So I'm going to undo the divided by 4 first. I'm going to multiply both sides by 4. Multiply both sides by 4. And when I do that, I divide by 4 and then multiply by 4 cancel out. So I'm left with just 2x plus 3 is equal to 2 times 4, which is 8. And by the way, if you guys have any questions whatsoever, remember you can send me a message on chat, which will be private, I believe. No one will see it but me. And you can unmute yourself, ask me a question as well. It's totally up to you. Okay, and then now we're back to what we left off on Wednesday type of thing. I'm going to subtract 3 on both sides. And like I was saying, even the harder stuff, after a couple of steps, gets back to the easy stuff, right? So minus 3 on both sides. I'm left with just 2x is equal to 8 minus 3, which is 5. And this is the same as questions 1 to 7 from Wednesday's homework. And obviously, we know we divide both sides by 2 here. And so you have x is equal to 5 divided by 2. Now you can write 5 over 2. You can write 2 and a half, or you can write 2.5. It's all the same. Whatever you prefer. Doesn't worry me at all. They're all correct. Okay. Moving on. So what about if you have something like this? Well, I'm going to undo. And remember, by the way, you can choose which letter to undo, which letter to get rid of. It doesn't matter what order you choose. So you know what, I mean, there are some easier methods, I guess. Some things which are slightly easier, but some students, some very small students, they look at this type of question and they don't know how to start. And the thing is, it doesn't matter because you will get the same answer. So what I'll do over here is just as a sort of experiment. Over here, I'm going to get rid of the 4 first, and then I'll do the same question again, but I'll get rid of the 2 first. And then over here, I'll do the same question, but I'll get rid of the 3 first. Okay, and let's see how it all pans out. So over here, I'm going to get rid of the -4. How do I undo a -4? Add 4 on both sides, right? Same fundamental rule. It all really boils down back to the 4 basic things we can do. We can add a number to both sides, right? So you can add a number as long as you add it to both sides. You can subtract a number as long as you subtract from both sides. You can multiply as long as you multiply every term on both sides. And you can divide as long as you divide every term on both sides by the same number. So over here, I'm choosing to add 4 to both sides. So to get rid of that. So now I have 3x over 2 is equal to 2 plus 4 is 6. And because this is a divided by 2, I'm going to multiply by 2, multiply by 2 there, multiply by 2 there. And that's going to cancel out. I'll be left with 3x is equal to 6 times 2, which is 12. And then I divide both sides by 3. And that's x is equal to 4. Now, what about if you had decided that, you know, like I was saying earlier, some students get confused about what to do first. And the thing is, it doesn't matter what you do first. Let's say I decide to get rid of that divided by 2 first. How do I undo a divide by 2? Multiplied by 2. So I'm going to multiply every term on both sides by 2. Notice I'm multiplying every term on both sides by 2. It's so important that you multiply every term. I see so many students make the simple mistake of thinking, oh, I'm moving a number. You're not moving a number. You can't say I'm moving the 2 there. You will get it wrong. That's not what you're doing. Okay, I stressed this on Wednesday. I'm going to stress it again. You have to understand the basic operations you're allowed to do. So you can multiply every term on both sides by 2. That's a perfectly valid operation. So let's see how it pans out. That cancels out. 3x and -4 times 2 is -8 is equal to 2 times 2 is 4. Now I undo the 8 plus 8 here plus 8 there. 3x is equal to 12x and divide both sides by 3. So in fact, I won't skip the step. So divide this by 3, divide this by 3. You have x equals to 4. And notice you get the same answer. Same answer. It doesn't matter how you do it. And let's say we'll do one more thing. 3x over 2 minus 4 equals to 2. And let's say you decide to get rid of, let's say you decide to undo the 3 first. Perfectly fine, as long as you divide every term on both sides by 3. And look, it won't be as straightforward as the first 2 solutions were. But I'm just trying to show you that it doesn't matter what you do first. As long as you do it correctly, as long as you apply the 4 basic rules correctly, you will not get a question wrong. There's no such thing as the correct way, so to speak. There's 4 rules. You apply them however you want, whatever you're comfortable with, and you will get the same answer. So let's say I divide everything by 3. Every term, I divide by 3. So that 3 and this 3 cancel out. So I'm left with x over 2 minus, and 4 divided by 3, I'm going to write as 4 over 3 is equal to 2 divided by 3, which is 2 over 3. And yes, that looks quite a bit more complicated than the first 2 steps, which is why I wouldn't recommend it. However, if you learn it and you know what you're doing, you will get the right answer. Okay, so let's say I get rid of that divided by 2. Or actually, let's add 4 over 3 on both sides. I add 4 over 3 here, and I add 4 over 3 there. Let's see what happens. So you have x over 2, and that's going to cancel out, is equal to 2 over 3 plus 4 over 3. That's 6 over 3. You know what? I'll use a calculator. I can do it mentally. 6 over 3, which is 2. But let's just use a calculator. whoops, 2 over 3. And then I'm doing plus 4 over 3 and gives me 2. So calculator gave me the answer 2. And now I'm going to multiply both sides by 2. Multiply that by 2, multiply this by 2. X equals to 4. Exactly the same. X equals 4, X equals to 4, X equals to 4. You get the same answer. So it doesn't matter what you do first. However, as a tip, I guess, the one that works out to be the easiest, perhaps, is if you get rid of the thing that is furthest away from X first. Okay, and now that it's like I said again, it doesn't matter if you don't get that. If you're not sure what I mean by that, it doesn't matter. But I guess what's right next to X is the 3. It's literally joined to it. And then 2 is the next to it. And then you have -4. So I like to say get rid of the -4 first, and then get rid of 2, and then get rid of 3. It just generally works out to be fairly straightforward and easier than the other options as a general rule. But if you spot a different way, if you think another way is easier, that's fine. As long as you apply the rules correctly, you will get the same answer. Okay, last question for today. A word problem. It says find the value of X. The area of the rectangle ABCD shown is 24 centimeters squared. So the area of this rectangle is 24 centimeters squared. So let's start off with area of a rectangle. Area of rectangle, I know, is going to be the width times the length. I know that straight up, just general formulas, right? How do you find the area of this rectangle? Width times length. Now, the value of X, if the area of the rectangle is 24, they've told me the area is 24 centimeters squared. So 24 is my area. And what's my width? X plus 3. X plus 3. And what's my length? It's 4. So I can do multiplied by 4, or I can just write it over here. It's the same thing. It'll just make it easier for me to expand. That's just 4 times X plus 3. And I was going to write X plus 3 times 4. Same thing. 3 times 4, same as 4 times 3. So it does no different. So now I can expand. And let's say if you didn't want to expand, you want to get rid of the 4, you could certainly divide everything by 4 as well. In fact, let's try it this way. Like I said, you can do anything as long as you do it correctly. So I'm going to divide every single term by 4. Notice this whole thing is one term. Okay, so I'm going to divide this by 4 here, divide that by 4, and I'll be left with X plus 3 is equal to 6. 24 divided by 4 is 6. And then I subtract 3 on both sides, and you have X is equal to 3, and I'm done. And we can check that. We can check that by substituting it in. If X is 3, then that would be 3 plus 3, which is 6. And 6 times 4, the area of this rectangle should be 24. And you can see it actually is 24. And so it all works out. So I hope that helps. I'll stop the recording now, and I'll entertain questions after that.